Alright, so section 5, Ionic Nomenclature. So now we're going to focus on naming ionic compounds. So some important things you need to keep in mind. Ionic compounds are going to be binary compounds. So it's going to be a metal bound to a nonmetal, or something bound to a polyatomic ion in some cases. And in this case, we have two components for the compounds that we're going to see, which are binary compounds. The two components are going to be a cation, a positively charged part of the compound, and then an anion, a negatively charged component. So we have a cation and an anion. And of course, we can have more than one anion and more than one cation. So the designated name will be based off of the component ions, and ionic compounds are written empirically, or with the lowest whole number ratio. So for example, and let's just say here real fast, I'm not going to see Al2F6, I'm just going to see AlF3. So we already know oxidation states. We really don't need to go too much into it, but the one thing we should probably mention is that when we talk about ionic compounds and how to name them, a lot of times we could just be given, oh, here's the name, what does the structure look like? And so sometimes, let's say, if I'm given magnesium bromide, if I just heard it, I would automatically think MgBr. So yeah, I can really see a lot of different combinations, magnesium bromide, MgBr, but I have to remember the charges. And if I'm not shown a charge, because there's no charge written for this ionic compound, then the overall charge has to balance out. So MgBr, I would think, is just 1 Mg, 1 Br, but magnesium, which is in group 2, has a +2 charge. Br has a -1 charge. So I'm going to have 2 bromines for that 1 Mg. So the formula would be MgBr2. So let's get into naming the simplest form. So naming simple ionic compounds with monoatomic ions. So that's just like what we saw before, MgBr2. There's no polyatomic ions, or ions that are just a conglomerate of different molecules bound together. It's just going to be one cation element bound to one anion element, or to whatever the charges balance out to be. So naming the cation, we just simply use the element's name. So magnesium bromide, the cation's magnesium, we call it magnesium. And for the anion, we don't call it magnesium bromine, we call it bromide. So we change the suffix to ide. So MgCl2 is just going to be magnesium chloride. And what is the empirical formula for sodium oxide? Well, oxygen, has a -2 charge. So that's -2, and I know sodium, which is in the group 1, has a +1 charge. I'm going to need 2 sodiums to balance out the oxygen. So I would be Na2O. And it says empirical, which means the lowest whole number ratios. And so Na2O, I can't break that down any further without getting a decimal, so I know that's the final empirical formula. Now we get into those conglomerate ions, or the polyatomic ions. So naming the cation, if it's monoatomic, same exact thing as before, magnesium, still magnesium. If it's polyatomic, we just use the polyatomic cation's name. And we'll have an entire list of polyatomic cations, but there's only one real polyatomic cation that you need to worry about. We'll get into in a second, but that's NH4+. Naming the anion, we change the element's name to end with ide instead of "-ine", or "-ine", whatever the suffix originally was. And if it's polyatomic, use the name of the polyatomic ion without, so yeah, don't change the name of the polyatomic ion if it is an anion. So bromine becomes bromide, but some of the polyatomics that you'll see don't change the name. If it ends with, like, let's say a polyatomic ion is chlorate, it'll still be chlorate. So now we have a list of the polyatomic ions that you need to remember. So there's a few simple ones, and I'll probably just run through those first, the ones that you should know. It's also going to be really important that you know the charges on these. So OH, you probably know sodium hydroxide. So you know that OH is going to be -1. CN, you probably heard of like sodium cyanide. So again, it's -1. SO4 is sulfate, -2. PO4 is one of the only ones that you really have to see. It's actually the only one on this list that has a -3 charge. Everything else that's anionic is -2 or -1. So phosphate. NO3, if you've heard of sodium nitrate, it's again -1, +1 charge on sodium. CO3 is carbonate with a -2 charge. You might have heard of its protonated form or its conjugate base, HCO3, which is bicarbonate, if you've heard of sodium bicarbonate, which is like a weak base. It's also one of the ways we transport carbon dioxide in the blood. O2, if you know hydrogen peroxide, that's H2O2, so it's just O2 with a 2-. MnO4, permanganate. Now, the ClO4 and all of that stuff, that's usually the ones that people kind of struggle with a little bit. But so the thing I usually just remember is that ClO3 is where I like to kind of orient myself. It's like my ground level. And so that is chlorate. Most of these end with 8. This is no exception. And what happens when we have one oxygen less than the base? We change our suffix to "ite", so this is chlorite. What happens if we have 2 below? Well, if you've ever heard of sodium hypochlorite, it's even further below. So hypodermic needles just mean below the skin. Hypo, of course, is the prefix, so hypochlorite. It's below chlorite. And then ClO4, what happens if we go above? We have perchlorate. Yeah, and now the cationic polyatomic ion that you need to know is NH4+, and it is ammonium. So for an example, you might see ammonium chloride. What is the appropriate name for NH4ClO4? Well, what are the substituent ions in this compound? Well, we have NH4 and then ClO4. ClO4 is perchlorate, NH4 is ammonium, so it is ammonium perchlorate. And then what is the empirical formula for magnesium hydroxide? Don't know why that one's thrown in there. Oh yeah, hydroxide. That is just Mg. And then Mg forms what charge? A +2. So it's not just MgOH, it's MgOH2, because you need 2 minuses to balance out the +2 charge on magnesium.